Hi, my name is Victor M. Biroña, and today I'm going to give you a presentation called Correlational Analysis using PSPP software. Today we have a big agenda. First, I'm going to remind you about the null and alternative hypothesis concepts. What is a correlational test? I'm going to present you the variables for this exercise, and I'm going to show you the PSP results, including plotter graphics and bivariate correlation. Finally, we're going to have some takeaways, and I'm going to take questions. Hypothesis is defined as a tentative yet testable statement which predict what you expect to find in your empirical data. A null hypothesis, HO, is a hypothesis set up to be rejected in order to support an alternate hypothesis, labeled HA. When used, the null hypothesis is presumed true until statistical evidence in the form of a hypothesis test indicates otherwise. Alternative hypothesis is the opposite to the null. It's a statement expressing a relationship between two variables or indicate differences between groups. Hypothesis testing includes four important steps. The first is to state the null and the alternate hypothesis. The second step is to choose the appropriate statistical test, depending on whether the data collected are parametric or no parametric. The step number 3 is determine the level of significance desired. For example, p equals 0.045 or more or less. Step number 4 is to see if the output results for computer analysis indicate that the significance level is met. When the resultant value is larger than the critical value, the null hypothesis is rejected and the alternate accepted. If the calculated value is less than the critical value, the null is accepted and the alternate is rejected. The method to establish if a relationship exists between two variables is called a correlational test. We can categorize this correlation as positive, negative, or no correlation exists. We can visualize this test if the data is calculated in PSP and later converted in graphics using the plotter function. A 19th century English mathematician, Carl Pearson, developed a function to measure the linear correlation. Positive values means positive linear correlation. Negative value means negative linear correlation. 0 means no linear correlation. The closer the value is to 1 or to -1 means a stronger linear correlation. Evans, in 1996, proposed a table of R value. 0.00 to 0.19 is very weak. 0.20 to 0.39 is weak. 40 to 0.59 is moderate. 0.60 to 0.79 is strong, and 0.80 to 1 is a very strong correlation. Now we're going to do an exercise using the PSPP software. We're going to try to find the correlation between income and debt, income and savings, income and stocks, income and wallet, debts and savings, debt and stocks, debt and wallet, savings and stocks, savings and wallet, and stocks and wallet. The objective of this exercise is to find 6 significant correlations, and we're going to give a p-value of 0.05. For our first exercise, we're going to analyze if a correlation exists between income and debt. After running the software PSPP, we found a 0.05 correlation. That means it's a very weak correlation and is not significant. When we analyze the variables income and savings in the PSPP software, we found a 0.91 correlation. This is a very strong correlation and also is a significant correlation. When we analyze the relation between income and stocks, we found a 0.19 correlation. This is a very weak correlation, but still significant. When we analyze the variables income and wallet, we found a perfect, very strong correlation of 1.00 and also is significant. When we analyze the debt and savings variables, we found a 0.03 very weak correlation, therefore is not significant. When we analyze the debt and stocks variables in the PSPP software, we found a 0.05 very weak correlation. Therefore, is not a significant correlation. When we analyze the debt and wallet variables in the PSPP software, we found a 0.05 very weak correlation. Therefore, is not a significant correlation. When we compare savings and stocks variables in the software PSPP, we found a 0.28 weak correlation, but still a significant correlation. When we analyze the variables savings and wallet, we found a 0.91 very strong correlation. Therefore, is a significant correlation. Finally, when we analyze the stock and wallet variables in the PSPP software, we found a 0.19 very weak correlation, but still a significant correlation. Some important takeaways for today's presentation are the following concepts. The p-value is the probability that you will have found the current result if the correlation coefficient were in fact zero, null hypothesis. If this probability is lower than the conventional 5%, the correlation coefficient is called statistically significant. You accept the null hypothesis or you reject the null hypothesis. The Pearson correlation coefficient, R, can take a range of values from +1 to -1. A value of 0 indicates that there is no association between the two variables. A value greater than 0 indicates a positive association, that is, as the value of one variable increases, so does the value of the other variable. Thank you for watching my presentation. Now, are there any questions?